In this video, we're going to talk about simplifying trig expressions. And so in order to be able to simplify trig expressions, you have to know the identities that are allowed to be used. And so there's these identities that we have, and I'm only going to talk about 11 of them here in this video, and I'll just kind of explain it. You have your reciprocal identities, you have quotient identities, and you have Pythagorean identities. These identities, the Pythagorean, or excuse me, we'll start with the reciprocal identities. These ones are pretty basic. They're just saying that sine is 1 over cosecant, and cosecant is 1 over sine, and you just have to memorize those ones. You should memorize them all, but quotient identities, hopefully you've learned about those before, and you know that, like, maybe in the unit circle that tangent is y divided by x, so that's kind of where that idea comes from. That's why we have tangent of an angle is the equivalent statement as sine divided by cosine, and so you should memorize those too. And then the Pythagorean identities you need to memorize, but what you also need to know about the Pythagorean identities is that these are, I don't know what the best way to say it is, but they're adjustable. And so what do I mean by they're adjustable? Well, let's just take this one for example. Sine squared of theta plus cosine squared of theta equals 1. Well, you can subtract cosine squared from both sides, and so then we could say sine squared of theta equals 1 minus cosine squared of theta. So you might be simplifying an identity, and it would be better to use sine squared and say that it was equal to 1 minus cosine squared. And so it just all depends on kind of what you're working with and how things are going. And so you could even subtract the 1 back over and say that sine squared of theta minus 1 is equivalent to negative cosine squared. So these are all movable and adjustable to fit your needs however the problem allows. And so let's get to it. So when you are simplifying trig identities, what you want to do is you want to just kind of find the best way possible, and I'll try to give some tips of what you should look for. So the first thing, let's look at this example, is you're going to want to make sure you just use good substitution. So in a lot of the problems, you'll have to substitute equivalent expressions, and that's why I said you want to memorize those 11 identities. So you have, let's take this expression, cosecant of x times tangent of x plus secant of x. So the goal of simplifying is to make this smaller. So a lot of the times we try to write it with just one term if we can. If we can't, then we just leave it as whatever it needs to be. But substituting means replacing one thing for something that's equivalent. So cosecant is the same as 1 over sine. So I would replace that. Tangent is the same as 1 over cotangent, but that wouldn't really help me. What would help me is to do sine of x over cosine of x. And then I'm going to leave this over here for now. Oh, whoops, secant of x. So if you look at, now that I've substituted in these things, you can see that there's some things that will cancel out. The signs, when we multiply straight across, sine divided by sine will reduce. And so now we'll have 1 over cosine plus secant of x. And if you do have some of these things memorized, you know that 1 over cosine is equivalent to secant of x. And so now we have, right, secant of x plus secant of x, and we have 2 of them, so 2 secant of x. And that would be how you would simplify that expression. So substitution is something that you want to do. The thing about substitution is you want to make sure you're substituting in things that are helpful. So if you had put in 1 for tangent, let's say, if you had put in 1 over cotangent, nothing would have simplified, it wouldn't have been very helpful, And so that's why you want to be real strategic with what you substitute. The second example, we're going to do 2, and that's going to use 2 of them, and we're going to use factoring. So the second thing you can do when trying to simplify is you can factor. And so take a look at A here. We've got 1 minus 2 sine squared of x plus sine to the 4th of x. And so the thing about this is it's a trinomial, and everyone looks at it and sometimes they freak out because they're like, oh geez, that's a lot going on. Well, think of sine as just a variable. So what if a teacher had asked you to do 1 minus 2x squared plus x to the 4th? What if they had told you to factor that? And so if they had told me to factor that, I would try to factor it like I would any other trinomial. Just try to figure out what would be my 2 binomials that would help me FOIL to that trinomial. So I know what multiplies to 1, that'd be 1 and 1. And I also know what multiplies to x to the 4th, that's x squared and x squared. The only thing is I needed to add to negative 2x squared, so that'd be a negative and that'd be a negative. And so that's how it would factor. So the same is going to be true of this trinomial. Instead of using x squareds, I'll just use sines. So it'll just be 1 minus sine squared times 1 minus sine squared. And that would be how it would factor. Now then it allows you to substitute. So if you remember, I said that the Pythagorean identities, right, are movable. So cosine squared plus sine squared equals 1. If we subtract the sine squared over, right, then I'd have 1 minus sine squared. Oops. 1 minus sine squared on the other side, which is the same as cosine squared. So this would be cosine squared times cosine squared, which is cosine to the 4th power of x. Another kind of factoring situation would be greatest common factor, right? So happens a lot, just so that everyone can see it a little bit. Here you go. Let's take tangent squared of x minus tangent squared of x times sine squared of x. So when working with that, we notice there's 2 terms and they each have tangent squareds in them. And so we're going to take out the tangent squared, its greatest common factor, and leave me with 1 minus sine squared. And so hopefully that doesn't bother you and you have memorized what's 1 minus sine squared. We just did it and agreed. 1 minus sine squared is cosine squared. But the question you need to always ask yourself is, can you keep simplifying? So what do you know about tangent? You know that tangent is sine squared of x over cosine squared of x. And then you're going to do times cosine squared of x, which this is over 1, and so therefore these things will reduce. And so your answer would just be, it simplifies to sine squared of x. And so those are just a couple ways in which you can simplify trig expressions. I can't do them all, you know, there could be lots of situations, but this is the first video of 2. So this is the first simplifying trig expressions video. There's going to be another one on the way. So talk to you later and have a good night.